Okay, so you have completed in your PSMT the introduction, mathematical concepts and techniques, observations, assumptions, and your solve section. And now you're up to your evaluate section. So for the evaluation, you can see all of the things which are going to be marked. So you're going to get a tick for each of these. These are the A level. Have you verified your results? Justified statements about reasonableness based on assumptions, based on observations, strengths of the solution, and limitations of the solution. So the first one, verified results. How can you prove your answers? Your answer is correct. How do you verify this? Now, there are lots of different ways. One suggestion would be online calculators to do this. So did you determine the cost of tiles within a small house? If so, you'll find an online calculator that will allow you to punch in some dimensions and work out a cost, and then you can compare your answer to their answer. Now, just because your answers differ doesn't mean that your solution is incorrect. Your solution is probably correct based on the assumptions that you made. The online calculators will have more information in them potentially, therefore your solution could be different, but you explain that and you're hitting that justification, and you're actually getting better marks by explaining that. All right, so did you need to paint something? Here's another example. There are lots of places online where you can punch in your wall dimensions throughout your house, and it will determine the amount of paint and the cost that is going to be, and that would help you look at your answers and determine, how close or how good your answers were. Okay, did you carpet or tile something? There's online calculators for that. There are different things, like if you were putting in a line of best fit or you were calculating a line of best fit, then Excel can do that. Excel can make predictions and so on. Okay, so this is how you can verify that your results are close, particularly close, or not close at all. Remember, they don't have to be. It's great if they are, if it's an accurate math thing, but for paint calculations and all of that, it will just need to be close to verify. Okay, there's the line of best fit example there. So you do need a section that discusses how good your answer actually is as an answer in and of itself. How can you verify that? Now, the next one is to evaluate the reasonableness. This is your solution. Read all of these criteria. Reasonableness of the solution. Reasonableness of the solution. Is your answer good based on your assumptions? Is your answer good, reasonable, based on your observations? So it's about your solution, your overall answer or answers, depending on what you were asked to do. Is it a good solution? Is it reasonable? Is the cost of $2,000 to paint the house a reasonable solution? You have accurately used math to get to this answer, but is the answer actually reasonable? In the real world, would it actually cost $2,000? Now, is it a good solution, or are things not that good, right? Or just elements of it that are not good? And it depends on the observations and the assumptions that you made. All right, here's an example of that. Just before we go, hint, use a table, right? If you have the original observation that you typed at the beginning here, and then you put reasonableness of solution, you're more likely to hit that reasonableness, as well as if you start with the solution is reasonable, or you start with the solution is not reasonable. Okay, then you're actually going to hit these criteria. So let's have a look at this one in depth. The office building must be constructed primarily from shipping containers. The solution, so my design of the tiny office, is reasonable based on this observation because only shipping containers were used. So in the solution, there were 3 shipping containers joined together and they made the office. They were joined together with no need for a hallway or breezeway or any other material. So my solution is reasonable based on this observation. I didn't use anything else. I used shipping containers. Okay, this one, the office building must contain a meeting area, kitchenette, space for 2 office desks and a staff lunch area. That's your observation originally used. Here it is here. The solution is reasonable based on this observation because all required elements were placed into the design and there is room to move around and work in the space as was also required. So my solution is reasonable. I didn't miss any of these things. So that's what you want. You want the table, put the original observation in there word for word. That's okay. And then you're talking about the solution is reasonable or the solution is not reasonable. Now let's have a look at some based on assumptions. So the shipping containers can be easily joined together to create a space being designed. That was an assumption. I don't know that you can actually join two shipping containers together without any kind of other material, so I just assumed it, right? My solution, the solution is reasonable based on this assumption, as only shipping containers were used. However, if this assumption is wrong, if you can't just simply put them together and weld them together, then the overall cost in the solution, so my solution isn't reasonable anymore, right? The overall cost of my solution will be lower because you'll need other materials to join the shipping containers together. So my solution is reasonable provided that you can actually just weld shipping containers together and make a house. But if that's not the case, if you need some extra metal or some woodwork to create a hallway to join shipping containers together, then my solution is no longer reasonable. Okay, so that's the kind of thing that you're looking for. There's another one there that you can pause the video and you can have a read. Right, you need to explain it. You need to justify it. That's your justify word there. But it's about whether or not your answer is reasonable. Is that cost reasonable? Is the design reasonable? And it can be both reasonable, provided the assumption or observation is fully correct, and unreasonable if your assumption was wrong. Okay, so that's one way to go. The last 2 dot points here are your strengths and the limitations. Now, note, it is plural, strengths and limitations. So you need at least 2, and you need to explain them. Again, hint, massive hint, use a table, put the strength here, and then this is a strength because. When you attempt to explain why it's a strength, you're having the potential to hit this word justify. So, the solution meets all the criteria listed in the requirements section. That's a strength. You were asked to put all these different things in or to do all these particular things. There are criteria. If you met them all, then that's a strength, right? The customer will be happy that the criteria is all met and overall cost. Okay, another kind of strength is the solution is simple design, but you can change it. You can incorporate more. If they come back at you and say, you know what, we actually need a bathroom in that tiny office. We forgot people need to go to the bathroom. Then you can say the design is easy. Another shipping container could be thrown on to create that bathroom. Right? It's a strength because we've got everything they asked for, but it's so easy to see how to develop a solution within the PSMT that we can easily add in something that they need. Okay, now limitations, same thing, use a table, limitations. This is a limitation because if you attempt to complete this section of the table, then you're attempting to get this justified bit here. Right, the limitations, the biggest one for nearly all PSMTs is your design or your solution is based on a bunch of assumptions. If an assumption's wrong, your solution may no longer be relevant or correct. Okay, so if it's based on a bunch of assumptions and the assumptions are incorrect, right, like the assumption that the cost of the carpet includes underlay and installation, the overall cost is most likely too low and will blow out. Most ads say, oh, it's $45 a square meter. That's just for the material. You probably need to buy some underlay to put underneath it, or you might have to have your floors leveled, or you might not be able to put it in yourself. So you've got to pay someone to come and put it in. So you might have assumed that that cost per square meter included all of that, but in reality it might not have. So that's a huge limitation, right? And then you've just got to look at your design to think of some other limitations. The tiny office one, a porch area was included in the design to present the space what it could look like, but it wasn't a criteria that they asked for when they were saying what they wanted, and therefore you didn't do any of the costing for it, but the customer will look at that and go, oh, that porch is nice, and then when you build it, oh, there's no porch. So this could be a limitation. So you just need to think about your actual assignment and what is strong and what is limitations about it. Okay. Now, throughout your PSMT, you're trying to hit this mark for communicate using correct math language, logical organization. That's all the subtitles that you've seen in all of the other videos. And as you go all the way through, what are you doing and why are you doing it? Right? Use an appropriate language, use headings and subheadings to make sure that it's logical, person who's reading it knows what this math is about because there's a subheading. Okay, and always, always, always explain what you're doing in this section and why you're doing it. This will help you reach the justification of decisions if you're explaining why do you need that area? I need that area to work out the cost of the grass in my garden design, etc. Okay, have fun writing your PSMT. Don't forget, there's all the other videos in this series for all the different sections for the Essential Math PSMT. Always, though, ask your teacher if you're on the right track. Don't just take my word for it.